Good evening, ladies and gentlemen. My name is Souvik, and I'm currently responsible for the AMETEK land business here in India. Today, I'm going to discuss about the temperature measurement technologies that land would offer in order to optimize the fired heaters that are present in various chemical and petrochemical industries. For the sake of this particular presentation, I'm going to limit the definition of fired heaters to ethylene crackers and steep butane reformers. Now, even before I start discussing about the product, I wish to set up a problem statement, okay? We are going to focus on reformer tubes measurement, but even before we go there, why exactly do we need to measure the temperature of these reformer tubes? First of all, it is critical for your process optimization, okay? We want to run these furnaces at maximum efficiency, and that is the reason why they need to run at their optimal level. Now, what does this mean? What exactly are we looking for when we, how exactly we define this word optimal? Well, optimal here means that how exactly the operator would manage the performance of this tube or the overall furnace based on getting out the maximum profit while ensuring that these tubes, they last for a very, very long time. Now, when it comes to operation of these reformer tubes, right, if the temperature is lower than the optimal level, then the furnace, they do not deliver the yield that they are targeting for. However, if the temperature is higher of these reformer tubes, they are higher than what's expected, then the life of these reformer tubes, they reduce drastically. The figures on the table that you see here on the right, you can see that a nominal temperature increase of about 20 degrees Celsius from the standard value results in decrease in life of these reformer tubes by 50%. So accurate measurement of the surface temperature of these reformer tubes is extremely, extremely crucial. Now, land offers technologies that would enable our customer to measure the surface temperature of these reformer tubes very easily and very efficiently. However, the furnace manufacturers have also thought of some solutions, okay? It's not like when these furnaces, they are built, they do not come with, they come without any sort of temperature measurement technology. Typically, we have, furnace manufacturers, they do provide solutions such as welded thermocouples, as well as using a reference tube as a measurement technique. However, these kind of measurement, they do have certain drawbacks, okay? These welded thermocouples, typically, they give you a single point measurement, right? And also they have, these wells, sometimes they are not very good, so they do not transfer the temperature data from the surface of the tube to these thermocouples very accurately. When it comes to these reference tubes, okay, even though they are made of the same material as that of the reformer tubes, they are of the same size, they are of the same dimensions, however, they are not exposed to the same kind of process parameters as the original tubes are. And that is the reason why they do not deliver very accurate temperature measurement. Now, when we compare these solutions from the furnace builders to the technology that land offers, we are offering three different types of temperature measurement devices, all based on infrared temperature measurement technology. However, in their physical form, they are very different from one another. One is a portable pyrometer. We call it Cyclops 390. The other one is a thermal imaging camera, or to define it more accurately, it's a boroscope type thermal imaging camera. And the third one is something that we refer to as a reference pyrometer, which is very unique to land, and we call it as a gold cup solution. Now, to understand this technology, you kind of need a a bit of understanding about how infrared works, okay. We are talking about a whole range of electromagnetic spectrum, and with our pyrometers, we are very selective about what wavelength we use for what measurement. Typically, when it comes to reformer tube temperature measurement, a 3.9 micron wavelength is considered to be ideal because it has certain advantages. When we look into IR temperature measurement, there are certain areas which are referred to as absorption bands. This means that if you select a wavelength within that absorption band, there's a tendency that a large amount of IR radiation will be absorbed in those bands, and the measurement that your IR pyrometer will give won't be very accurate. So we have to avoid these absorption bands to get the optimal temperature out of our IR measurement devices. Now, this 3.9 micron band is one such band that provides us with a window where the IR energy which is emitted by this tube, which by the way is a function of the surface temperature of the tube, is not absorbed either by CO2 vapor, water vapors, or the hot air, and it is also unaffected by something which is referred to as background temperature. Now, because this band is so unique, we use this 3.9 micron detector or sensor in multiple applications wherever we have to measure temperature inside a furnace. Now, this Cyclops 390 has actually become a gold standard when it comes to point temperature measurement of reformer tubes. Because of its ease of use, the price point that we are offering it, and at the same time, some additional features which puts this particular product ahead of what's available in the market right now. Here is a list of some specifications. When it comes to measurement of these reformer tubes, you need to understand that we are exposing these sensors in an environment where the target is at different distance from the particular sensor. So that means having a sensor with a variable focus is very important, because you are targeting objects which are very close to your sensor. At the same time, you do have a necessity to target objects which are far away as well. So this particular portable device comes with a variable focus option. Apart from this, because there's a large number of reformer tubes, you also want that your sensor should be able to save a large number of readings. The Cyclops 390 facilitates saving data up to 10,000 points. Okay, so you can actually go on and carry out your reformer surveys without even worrying about downloading the data, right? From a temperature range perspective, it is quite adaptable to the job that we have assigned it to do. So we have a temperature range starting as low as 450 degrees Celsius, going all the way above 1400 degrees Celsius. Now, when we typically look from an application standpoint, okay, this particular sensor is absolutely focused towards accurate measurement of reformer tubes. And you can see it in the specification as well. This particular sensor has an accuracy of 0.25% based on the temperature that it's measuring, okay? From a form factor standpoint, it is very, very ergonomic. So you can see that it has a front ring. We also provide additional protective window in case the ambient temperature is high. We want to protect our instrument from the heat that's coming inside inside the furnace. Then we have tripod mounting for the flexibility of measurement. Then there is adjustable eyepiece which comes with multiple filters so that the operator could easily view what he is targeting. So overall, a very, very ergonomic design when it comes to a portable handheld measurement kind of a sensor. Now, moving on to the second solution that we offer. So this is a thermal imaging camera or a boroscope camera. Now, from a wavelength perspective, we do have a 3.9 micron wavelength option. We call it the MWIR, or medium wavelength IR boroscope camera. But at the same time, we also offer a short wavelength version of it. That is the NIR version. Now, though the MWIR camera offers the flexibility of using the 3.9 micron wavelength, the fact that it comes with the advantage that it gives you very good IR measurement. From a technology standpoint, we are limited to a 640 by 480 resolution focal plane array when it comes to this wavelength. Now, certain customers, they are more demanding and they want to get a very, very high resolution image of their reformers. So to meet their expectation, we had to come up with this NIR camera, which now offers 2K resolution. To put it in simple terms, a 2K resolution has 4 times the number of pixels of a 640 by 480 resolution camera. So the kind of image that you get is a very, very high resolution thermal image. Now again, with this kind of technology, we have 3 different versions of these boroscope cameras. Number 1 is a portable version, so it's powered by a battery pack. That offers around 9 hours of battery life when you are carrying out your reformer surveys. 11 hours of battery life when you are carrying out your reformer surveys. It has excellent accuracy and repeatability. We are actually very proud that we are, pioneers when it comes to providing very, very high accuracy thermal imaging cameras to the market. So the accuracy here is defined as 1% of the reading, and you can see that it also has excellent repeatability of 1 degree Celsius or 1 degree Kelvin here. When it comes to managing the ambient temperature, because you are putting these boroscope cameras inside the furnace, we do provide an option for air cooling or water cooling. Now, another alternative to this system is fixed version of these cameras, or cameras which are mounted on a retractable system. Now, these cameras are for customers who are more interested in having continuous measurement of the reformer tubes within their furnace. Now, it's not possible to cover the entire furnace using a single fixed camera. So definitely we understand the furnace design of our customers, and then based on some 3D modeling, we do suggest that what kind of field of view and how many cameras would you eventually require to gain the maximum coverage of your furnace. So there's a whole lot of discussion that goes on before we suggest a certain model and field of view for these type of cameras. Now, for a fixed installation, we have to take into account certain, certain things, such as in case of abnormal operating conditions, let's say the water flow for the camera cooling system fails, or the air purging system fails, or let's say for whatever abrupt operational reasons, the lens tube temperature of my camera goes beyond a specific limit. So all these fail-safe, they are taken into account, and we ensure that the camera, it retracts in event of a in case of an abnormal event that might happen, okay? So we have that kind of fail-safe measures in place for these kind of fixed cameras. Then the third and the final option that we have here is for our customers who define the area around their furnace as hazardous area. So for those kind of customers, we do offer our NIR-B cameras in ATEX housing as well. So these right now we do not have a 3.9 micron version of this camera because of some technical challenges that we have, but the 1 micron version is available. It's available in air-cooled as well as water-cooled option. The choice of this option depends on the furnace temperature. And then this particular system, it's a fixed camera system. It does not come with a retractable mounting because we have to install it in a hazard-prone area. So we spoke a lot about camera technology. We spoke a lot about infrared temperature measurement. But then our customers do often ask here, how do I ensure that the camera is measuring accurately? No, yeah, before we go to that, I wish to show you how exactly the images, okay, of these particular cameras, they look like. So here on this particular slide, you are looking at image from a NIRB 2K camera. So this particular camera provides the highest resolution images, thermal images that are available in the market right now. It's a 1 micron wavelength camera, and from a resolution perspective, like I have explained earlier, the 2K resolution is defined as 4 times the resolution of a typical 640 by 480 resolution camera. So you receive a very, very high quality thermal image stream from this camera. Now, if you have to compare a 2K resolution image with a 640 by 480 resolution image, that is something that you are looking at the screen right now. You can see that the image on the left is much well defined compared to what you see on the right. This is another example where you can see how a thermal imaging camera could very easily identify the problems that's happening inside the furnace. If you look at the brick wall towards the end, you can clearly see flame impingement, meaning that your heaters, okay, or your burners, they are actually not heating the pipes. Instead, they are the flames, they are heating the wall, which is resulting in high wall temperature. At the same time, around that area, you could see that those tubes, they appear in light blue color, indicating that they are not heated as proportionately as the rest of the tubes. So the uniformity of the heating of the tube is simply not there. On the bottom right side of the picture, you can also see a hot spot, which is showing in this thermal image, indicating a damage on the tube surface. So all these indications, okay, that you see are very clearly visible when you use a high resolution camera like the NIRB 2K. Further, this is another example where you can very easily see the deformation of the tubes, okay. The image on the left, it shows a picture which is taken right after the commissioning, and on the right you see an image which has been taken around 2 years after the commissioning, okay. So you can clearly see the damage that has happened due to incorrect operation. Yeah, now coming back to the topic where, our customers would come up to us and ask, how do I verify the accuracy of my pyrometer? So Land is the only company in the globally which manufactures a reference pyrometer for tube wall temperature measurement. We call it the Gold Cup pyrometer. And this particular pyrometer basically helps you identify the true temperature of the surface by being in physical contact with the surface of your tube. Now, the best thing about this particular solution is that you can use the Gold Cup pyrometer to calibrate any IR device that you are using to measure your tube wall temperature. Now, of course, there are always pros and cons to these kind of solutions. You cannot measure each and every tube using a physical contact type Gold Cup solution, okay. So this particular solution is only used as a reference to calibrate your other IR pyrometer device. So these are the 3 basic solutions that Land offers at this point of time for tube wall temperature measurement. We have a booth here. Please do come to our booth, and I would be happy to answer your questions on tube wall temperature measurement tomorrow. Thank you. Thank you for your time.